Okay, geometry lesson 41, ratios, proportions, similarity. It starts in your book on page 266. We're looking largely at triangle similarity. A ratio is a comparison of two values by division. It's also, ratio sounds a lot like rate. So like miles per hour is a rate. Calories per ounce is a rate, right? It's the comparison of two variables separated by division. Okay, the ratio of two quantities A and B can be written in three different formats, and A to B is in A to B. Not really. Let me change this. If it'll let me. A to B, A colon B, or A over B, where B does not equal 0. Why can B not equal 0? In a ratio given like this, why can B not be 0? It would make it undefined because B is in what position in that fraction? The denominator position. I'm not allowed to have 0 in the denominator. Okay, so B can't be 0. A statement that two ratios are equal is what we call a proportion. So whenever I have a fraction equal to another fraction, we call it a proportion. Just a fraction is a ratio. Okay, in the proportion, A over B equals C over D. A and D are the extremes. B and C are the means. When we talk about geometric means, what we're talking about are the bottom left and the top right. That's a lesson for another day, but we'll get into that. So top left and bottom right are the extremes. Bottom left and top right are the means or the averages. Okay, one way to solve a proportion to find a missing value is to use cross products or cross multiplication, or you've heard the phrase cross multiply and divide if we're trying to solve for a piece of that. And I know that you know this because you were taught this by Mr. Spears, right? Okay, so everybody in here should know how to cross multiply and divide because, he's the superhero of the math department. Everybody remembers everything Mr. Spears ever taught them, right? Because he screamed it into your head. Okay? So, that was one of the hardest things whenever I first became a teacher, is that I had middle school math. And so I had everybody coming straight from Mr. Spears into my class, and I was a first-year teacher, and the number one thing I heard every day was, that's not how Mr. Spears taught it. I'm like, I don't know who this Mr. Spears guy is, but he's driving me nuts. So anyway, but I do remember explicitly, he taught us the butterfly method, right, on how to solve proportions. So you guys have been doing proportions since like early middle school, correct? So there's no reason that and here we are, we're in geometry. We're in geometry. You guys are sophomores in high school, and you're still doing the same stuff that Mr. Spears taught you way back in early middle school. So you guys should have this down pat. All right, the cross product is the product of the means and the product of the extremes. So top left times bottom right equals bottom left times top right. Right, we got this? Right, cool. All right. Anytime now. Okay, I'll just do it myself. Okay. All right, so two figures that have the same shape but aren't necessarily the same size are what we refer to as similar figures. Okay? What we're looking for are figures that have corresponding sides that are proportional, but corresponding angles that are equal, are congruent. Does that make sense? Right? Most notably with triangles. So what I've tried to draw up here, which is really difficult, is that angle A is equal to angle D, angle B is equal to angle E, C is equal to F, but they're not congruent figures because their sides aren't congruent. 3 is to 6, or AB is to DE. AC is to DF, and BC is to EF, and notice that the proportion stays the same. 3 to 6, 2 to 4, 5 to 10. What is the simplified ratio? What? Times 2, or 1 to 2, right? Does that make sense? 3 to 6 simplifies to 1 to 2. Okay? If I'm going back the other way, right, if I'm going 6 to 3, I'm seeing that triangle DEF is twice as big as ABC. 2 to 1 if I'm going back the other way. So that becomes important whenever they say, what is the ratio of this figure to this figure? The order matters, because they may say, what is the ratio, or what is the similarity or scale factor of triangle ABC to triangle DEF, in which case we'd say 1/2. But if they said, what is the scale factor of triangle DEF to triangle ABC, we would say 2. Does that make sense? So how they word it matters, because there's more than one way of looking at it. Okay. So these figures are similar. In this diagram, triangle ABC is similar to triangle DEF. All congruent figures are also similar figures, but the converse is not always true. Not all all congruent figures are similar. Not all similar figures are congruent. Does that make sense? Hopefully, a little bit. All right, in similar polygons, so it's not just triangles, the corresponding angles are congruent, the corresponding sides are proportional, but they all have to have the same scale factor, okay? If I came up here and I changed just one of these to something that isn't going to have the same scale factor, like let's say I say that this is 15, right? Well, 3 to 2 is 1/2, and 2 to 4 is 1/2, but 5 to 15 is 1/3. Are those figures similar now? No, because they're not proportional all the way across. Okay? So it has to work. All corresponding sides have to have the same proportion. Does that make sense? Okay? Let's see. Has the same proportional relationship as what you see about 2 sentences down. A similarity ratio is the ratio of 2 corresponding linear measurements in a pair of similar figures. The following similarity ratios can be written for triangles ABC and triangle DEF. Now, I've written them out this way. Hopefully we still make them out, even though they're not shown in that kind of classic this over this format. And if I can rewrite it, I will. If I've got room, let's see. Let's do it up here. What you're seeing here, DE over AB equals 6 to 3 equals 2 to 1. And that, you'll see, follows throughout the whole thing. EF over BC equals 10 over 5 equals 2 over 1. FD over CA equals 4 over 2 equals 2 over 1. They all have the same scale factor or similarity ratio. So like congruence, similarity is a transitive relation. A is to B, B is to C, A is to C. That same thing is true here in similarity. The transitive property of similarity states that if A is similar to B and B is similar to C, then A is similar to C. Okay? Similarity statement is a statement indicating that 2 polygons are similar, much like when we make a congruent statement. The only thing that's different is instead of saying triangle ABC is congruent, where we have that symbol, right? Triangle DEF. Okay? Because they're not congruent, they're not equal to each other, we throw away the equal sign and we leave just the similarity symbol. Because congruence actually means that they are equal and similar, okay? But not everything that's similar is equal, okay? So we understand, hopefully we know what we're doing whenever we see that similarity symbol show up. If you look on your keyboard, they actually exist there right above the tab button on the keyboard. I believe it's on your Chromebook. You see it? Little squiggle, okay? So you know where it's at if you ever had to use it for your computer. All right, let's look at a couple of questions here, and then one of the things I want to start doing. We really don't do letters in here, but I do want to see. Let's see, question 41. All right, what's your homework assignment for this lesson? 2 through 30 even. Okay, I'm trying to see if there are any questions from this lesson in your homework today. And number 2 is, so I'm going to work out some of these and then we're going to work out number 2 together, okay? So we're actually hitting something that's in what you have to do. Here they tell me triangle ABC is similar to triangle DEF. We want to find X. Okay, so we're going to set up a proportion, right? So there are a couple ways to do this. We can do big triangle over little triangle. We can do big triangle over big triangle is to little triangle over little triangle. Big triangle over little triangle is to big triangle over little triangle, that type of thing. You understand what I'm saying? Okay. What do we want to do, Chandler? Big triangle over little triangle. So tell me what you're going to use for your first ratio. X over 2. Very good. Equals what? Well, in order to have a proportion, we need to have two ratios that equal each other, right? So you've given me one ratio. You said X over 2. It's got to be equal to what? No. All right. So let's go back to, we'll take a big step back. Okay. These figures are similar, which means we know two facts for sure. Okay. We know that their angles are congruent to each other, right? So D is equal to A, F is equal to C, E is equal to B. The other thing is that we know all of their sides are proportional to each other. Okay? Not big triangle to itself necessarily as much as big triangle to little triangle. Okay? So you recognize that X was to 2, right? It was a corresponding side. So I want another side of my big triangle, and I want it over a corresponding side of the small triangle. So 15 over 5 would work. Okay? Now we want to solve that. So what do? What is X times 5? 5X. Good. All right. What do I get on the other side then? 2 times 15 is 30. Now I want to solve for X. Divide by 5 on both sides. X equals what? X equals 6. Good. So 6 over 2, right? And I should be able to notice 6 over 2 is what? 3. What's 9 over 3? And what's 15 over 5? All right, so my scale factor remains the same, right? That my big triangle is going to be, each side is going to be 3 times longer than the corresponding small triangle side. Does that make sense? Okay. All right. Okay. Let's see. I feel like we should be able to do 2. Does anybody feel like, Maddie? All right. Maddie, number 2. Can we solve this proportion? Okay. Tell me what I see you're working your calculator. Tell me what you're doing. 4 times 3. What is 4 times 3? Okay, so I'm getting 12 equals what? So you did this equals, what do I multiply next? 12 and what's left to multiply? 12 into x. What is 12 times x? 12 what? 12x. Okay. Okay, I want to solve for x. How do I solve for x? By? Divide by 12 on both sides. That's going to isolate that x. What's 12 divided by 12? 1. So 1 equals x. for x equals 1, right? What's that? Okay. And what we could do, if you look at this, we could even take 3/12 and reduce it. 3 divided by 3 is 1, right? And 12 divided by 3 is 4. So if I look at it like this, could I see that 1 is equal to x because 4 is equal to 4? Okay, so I could even reduce that ratio and get a little bit closer to the answer that way as well. Okay. Let's see. Let's do one more. Okay, let's do number 6, and then let's skip into your book. Okay, find the unknown side lengths in the two similar triangles. Jordan, help me set up a proportion. Let's solve for A first. 4 over A, okay. Okay. Which do you want me to do? And is there a difference? There's not a difference? So I can do that. You're on the right track. Okay. I have to do 7 over 21 because you're doing little over big. I can't do big over little on the other side. Okay? I got to keep them going the same way. All right. So, okay, let's keep solving here. Okay, 21 times 4 is 84. Okay. Okay. Divide 84 by 7. Okay, what do you get for 80? Okay, we get 12. Okay, so we can go ahead and put that in there. Okay, now my recommendation on solving B is don't use 12 over 4 or 4 over 12 if I don't have to, because it's found information, right? If this was a 2-point question, I wouldn't want to base the second part of the question on the answer that I got on the first part, because I might have been wrong on the first part. You know what I mean? Okay, so you're doing 10 over B, okay? Okay, do 7 over 21 again, okay? B equals 30. Good job. Okay, we get this? All right, so I'm going to come back to my geometry notes here, go over a page, and let's look at question number 2. Question number 2 in your book, page 2, says if the equilaterals, notice that these aren't triangles in this case, right? These are quadrilaterals. Okay, if the quadrilaterals at right are similar, what is the measure of angle E? So this one's actually solving for an angle, and what is the length of XY? Okay, so let me try to draw these figures. I don't know that I'll do a very good job. Okay, something like this, W, Z, 73 degrees, X, Y, and this length here is B. Okay, over here we've got E, D, 3, G, F, and 15. Okay, so we want to solve for two things. One, we want to find angle E. Okay, angle E. Katie, can you tell me what angle E is? Angle E, this one right here. What is that angle measure? 73 degrees. How did you know it was 73 degrees? Because x is 73, and there's a really important phrase that existed in the question itself. Something that it told you. It told you that they're similar. And what do I know about similar figures? Their corresponding angles are what? The same, congruent, thank you. Okay, corresponding angles of similar figures are congruent. So the moment that they said similar, we knew their corresponding angles were congruent, and you could look at it and see that x corresponded to E, therefore E equaled 73 degrees, right? Okay. Next thing we need is we need the length of xy. We need to know what is B. Okay, what is that length? Okay, so I want to set up a proportion. Michael, how would we do this? Okay. We will wait on you. We want to find B. 2 over B. So you're saying little triangle over little triangle equals big triangle over big triangle, 3 over 15. Okay, it's fine. All right, what do we get there? Well, give me the step by step. Okay, 15 times 2 is 30 equals 3B. Divide by 3. B equals 10. So XY equals 10. Okay? All right, so that's number 2 from your homework. I think that's probably, I didn't see, actually, number 6 does show up in there. Take a look at number 6, see if that's something you feel like, yeah, well, I'm going to need that, or no, I think I've got this. Um, 54. Yeah, so the word you're looking for there is you need to distribute in number 6, okay, because it's x plus 2 times 27. So put that 27 on the outside of the parentheses of x plus 2, and then you have your 9 times 9. Okay, so yeah, you should get 27x plus 54 equals 81. Then you are going to subtract that 54 from 81. Okay. Okay, so we've talked about this. The question is about question number 4. Let me hit stop on this because it doesn't really pertain to this lesson.